And in this video I'm going to demonstrate how to do a factorial ANOVA. So I have my data set of blood pressures here, and I'm going to go analyze. If we're doing a one-way ANOVA, you can go compare means and select one-way ANOVA. But to do a factorial ANOVA, you have to go to the general linear model. Select univariate. In this example, so I have a series of blood pressures. I have baseline and follow-up blood pressures. So then I have a calculated change in blood pressure. So I'm going to make systolic blood pressure change by dependent variable. And then what I'm going to do is I'm going to put in the fixed factors as my independent variable the blood pressure class, whether it was normal, borderline, or high. And I'm also going to select whether they followed the protocol. Alright, so now we have a bunch of options here. We're going to select under options, and I'm going to select both blood pressure class and followed protocol for main effects, and then I'm also going to test for the interaction. So to be clear, a main effect is the effect of the independent variable on the dependent variable. An interaction occurs when the effect of the independent variable changes depending on another independent variable. So we're looking at, does the following the protocol or the blood pressure class, how does that, do they interact? So I'm going to select compare means, and by doing that I'm going to get a pairwise comparison of all of these different combinations. And I'm going to select, as always, descriptives, estimates of effect size, and my test of homogeneity. I'm going to click continue. The only other thing I'm going to select in this example are the plots. And what I want to do is I'm going to put the blood pressure class on horizontal axis, and I'm going to put whether they followed the protocol on a separate line. And I'm going to add this, and this is really a good way to look for the main effects and the interactions. So I'm going to click OK, and let's see what we have here. So of course, as always, we have our descriptive statistics for each of these categories. We have our test of homogeneity. Now, one thing to consider, now this of course is an example, but I have differing sample sizes, and I actually am failing the test for equality of variances. So if I was doing this for real, those would be two concerns I would have. But this is an example, so we're going to move forward. So when I get to my test of between subjects effects, I see under blood pressure class and followed protocol, in both cases I have a significant main effect. And when I look for the interaction of blood pressure class and followed protocol, there is not. I did not get an interaction. And let's take a look at the plot to really confirm what that really looks like. So as you can see in this example, my plots here, there clearly is a main effect of the blood pressure going from normal to hypertensive. And there also seems to be a main effect, a difference between whether they followed the protocol or not. But there is no interaction. These two lines are pretty evenly distributed. Let's go back and let's try a different example then. So instead of taking followed protocol, let's put in the region of the country. Now we're going to have to reset our plots here. And we're going to have to reset our main effect for region and our interaction for blood pressure class and region. Click continue and OK. And now let's take a look. So we have more options here, so my descriptives are a little bit larger. I'm still failing for equality of variances. But lo and behold, I now have a main effect for blood pressure class, a main effect for a region, and I have an interaction. I have a significant interaction here. So let's take a look and see what that looks like. Aha. So as you can see, I have my different blood pressure classes here. So there's clearly a main effect. But what I also see, what you see in the interaction, is one of these regions actually has, it's not a straight line. If it was no interaction, you would see pretty much 3 straight lines like we did in the earlier graph. But there's a little bit of variance here. There's a region. So there's one region that for some reason is creating a differential. Now in one of my other videos we actually solve for that because the baseline blood pressure actually was significantly higher in this group. So this would be a case then where we could actually run a analysis of covariance on top of this to control for the fact that this region had higher blood pressures. But in this straight factorial analysis, this we don't have to. We're not going to do that. Not in the context of this video. So thank you.